in chapter 9, we're going to cover something called Stoic Geometry, and Stoic Geometry is where we quantify chemical reactions. So we might say if I start with 10 grams of magnesium hydroxide and 4 grams of water, how much magnesium, I don't know, something could I produce? Okay, I'm making up that off the top of my head. How much of my product could I make? Okay, so that's what we're doing in chapter 9. We're quantifying these chemical reactions. In order to get there, we need to do a little review on converting between moles and molecules, grams and molecules, that kind of stuff. We got to go back to our T-charts, right? Everybody loves T-charts. Chapter 9 will be a lot of conversions like that, a lot of T-charts, so you better hope you like them, okay, because you will like them after chapter 9. Okay, so we're going to do a little review to that, and then we're going to do an activity today to continue to practice with that, okay? So let's go ahead and start, and we're going to do our basic conversions. So we'll go from moles to grams. So this should be a review. Okay, moles to grams. We're going to start with 0.894 moles of sodium nitrate. And we want to find out how many grams that is. Okay, so how many grams is in 0.894 moles of sodium nitrate? Okay, so you will need your periodic table out. Okay. So in a T-chart, when we want to do these conversions, what's the first thing we do? Write what we know. Good. So 0.894 moles of NaNO3. Okay, then we draw our T. We want to go from moles to grams. Can we go directly from moles to grams? No. Why not? We can go from moles to grams. We can go from moles to grams. What's the conversion factor between grams and moles? Yeah, good. The atomic mass, the molar mass, molecular mass, whatever. Okay, the molar mass. So we want to get rid of moles. Where does it need to go? On the bottom. And where does grams need to go? Okay. What does mole always get here? The 1. The 1. Good. NaNO3. And this is still NaNO3. In this next chapter, we will start dealing with 2 compounds in a T-chart. So we might go from sodium nitrate to potassium nitrate, right? We're changing compounds further in chapter 9. So you need to make sure that you're careful and really include all of these labels in our T-chart so we know which compound we're dealing with. Okay? What needs to go here? Right here it needs to be the molar mass. Okay, so let's calculate molar mass of sodium nitrate. Sodium is 23, nitrogen is 14, 3 oxygens is 48. Okay, so let's add those together. Is that about what you had? 85? Hopefully? Okay, good. Put that in my head. All right, so 85 goes here. Once we've got our units crossed, right, we're done with moles. We're left in grams of sodium nitrate. Is that what we want to be in? Yes. So what do we do from this point? Good. Multiply across the whole top, divide by the whole bottom. Okay. So 85 times 0.894. 75.99, good. Or 76 grams. Okay, does this answer match what we expected? Does it start with greater than or less than 1 mole? Less than. So that means our total amount should be coming out less than the molar mass, which it is. Okay. Questions there? This is review, coming back a little bit, hopefully. Yeah, okay. All right, good. Let's go grams to moles now. And we're going to do this one on your own. Let's say we start with 142 grams of... Okay, we can do salt, that's fine. NaCl. 142 grams of NaCl. I want you to convert to moles, and we'll see if we match. Good. 2.427 moles of NaCl. Very good. Okay, 2.43, that's fine. Did we multiply or divide here? Divide, right? We divided by. We started with much greater than 1 mole of sodium chloride, so we're going to end up with much more than 1 mole when we calculate that out. Very good. Any questions between that easy conversion? Okay, hopefully this is coming. Let's go now between moles and molecules. Yeah, what's important here when we look at molecules? Avogadro's number. And what is Avogadro's number? Very nice. Almost in unison. I like it. Okay. So let's say we start with 1.62 moles of potassium phosphate. 1.62 moles of potassium phosphate. We want to find out how many molecules of potassium phosphate are in that sample. Okay, so first things first, we're going to write what we know. Okay, we start with moles, which means we want to get rid of moles, so that goes on the bottom. And molecules goes on the top. Moles always gets the 1. And how many molecules are in 1 mole of anything? Good. Do we need to find the molar mass of potassium phosphate here? No, we do not need to do that. A lot of you will try to put in molar mass somewhere here, even though it doesn't really fit, but we try to do it anyway, okay? Pay attention to what we really need, okay? We're done with moles, so here we multiply across. Okay, agreed? Yes. Okay, very good. 9.76 times 10 to the 23rd. Okay. Let's try one backwards now. You're going to do the backwards one on your own. So let's say I start with 1.46 times 10 to the 25th molecules of water. And I want to find out how many moles that is. Okay, you're going to do this one on your own. 1.46 times 10 to the 25th molecules of water. How many moles that is? Should we be expecting greater than or less than 1 mole of water? Greater than. Good. We're starting with a greater than Avogadro's number. We should be having greater than 1 mole. Okay, what did we get here? Aiden, why don't you tell me what you got? Okay. 24.24? Good. Sorry, Aiden. All right. That's okay. All right. If you get a huge number here, times 10 to the 40 something, that means you forgot to use parentheses when you divide. When you divide by scientific notation, you either have to use the E button in your calculator, right, that EE, or you have to put parentheses when you divide by scientific notation. Okay, so when we do moles, you should not be getting a times 10 to the something huge number, right? Moles is a pretty reasonable number, pretty small to reasonable number. Okay? All right, let's go ahead and try our 3-step ones. So I start with 38.2 grams of lithium carbonate. And I want to see how many molecules are there present.
What is this for? Are we doing something that involves this?
So in chapter 9, we're going to do a lot of these T-charts that convert from grams to molecules, stuff like that. So we're just reviewing. Okay, this time I want to go from grams to molecules. Can we go directly from grams to molecules? No. What's our middleman? Moles. Good. So grams of Li2CO3 gives us 1 mole. And we want to get rid of moles, so it goes on the bottom next. I'm going to go 2 molecules. In terms of the molar mass here of lithium carbonate, what did we have? Yeah, good. 73.8 or 74, that's fine. Okay, now we multiply across the whole top, divide by the whole bottom whenever you're ready.